Greetings! In this video, we will be covering part 10 of CMP 1002 Object-Oriented Programming course. Here we will be covering operator overloading topic. As you all know, C++ has a lot of operators. These operators can be grouped into these different categories, like the assignment operator, the arithmetic ones, increment, decrement operators, comparison operators, logical ones, bitwise, and the compound operators. We have seen them and we have been using them extensively on integers, doubles, chars, these kind of primitive data types. Some of them, especially the assignment, we might have been using it between the objects, but not that much. The others, we haven't been touched on these things, how to use them in the classes. There are also some other operators that are seldom used, or you just know them as an operator, but you don't consider them as an operator. For example, new and delete are actually operators, but it just feels like they are kind of functions. Regular parentheses and square brackets are actually also operators, but they are a little bit strange operators, let's say. So, as I mentioned, normally operators are defined over primitive classes. However, if we need them, C++ allows us to define these operators in custom classes too. So, if we have this tank class that we have been using for quite a while now, and I have these two tank objects, I can actually write something like this: 50 tank equals 50 tank plus 40 tank, if I overload the addition operator. But you might be thinking like, what is the meaning of adding two tanks together? In physical real life, you don't add two tanks. I mean, come on, what do you do that? Do you put them on top of each other? It doesn't make any sense. But for example, something like this may make more sense. If 50 tank is greater than 40 tank, we might be defining a comparison between two tank objects. And then if we define such a logic, then this code makes, the second piece of code makes more sense, right? So, a little bit formal definition. So, you can define most of the operators for a given class. Not all. There are a couple of exceptions that you can overload, but most of them you can overload. And when you do that, it is called operator overloading. For many of these operators, when you're overloading an operator, it is basically like writing a function for that particular class. Okay? It is as if you have a superclass, and the superclass has a function, has a virtual function, and then you are overloading it with a different implementation. And this overloaded overloaded function has, as you can see, this is like a function call, right? A function declaration within the class. Name of the class, which is a return type. Operator within less than, greater than brackets, operator. So that is going to be the name of the function. And after that, there's going to be the arguments. So here, if your operator is, for example, addition plus, then your class, your function name is going to be operator plus. So imagine that you have a function whose name is operator plus. That is what it is. Nothing so different. Since addition, you know, when you are trying to add something, two objects of the same class, this, the first one is going to be the caller, and the second one is going to be argument. It's going to be an operand from the mathematical point of view. And the return type is generally gonna be the type of the class that you are doing the operation on. I mean, this is not the only way, and this is for some operators we will see in the like following slides. For some of these operator overloading scenarios, we will be using different prototypes, but this is gonna be good for many of them. In the argument part, we are using a reference variable. You do not technically need to make it a reference variable. It is gonna be just to decrease the memory usages. It's better for the efficiency. For the same idea, you can also omit the const keyword, but again, it is good programming practice. Okay, let's go down to actual coding and see how this overloaded functions were written and how they are used. For this one, I will be defining a completely different class. it's going to be called fractional. So the fractional will represent a fractional number. So 2 divided by 5, 6 divided by 7, something like that. But be careful, 2 divided by 5, I can also write it as 0.4. In that scenario, it's going to be a real number. But if I keep it as 2 divided by 5, it's going to be a fractional number. So a fractional number is represented by two numbers. A numerator, the one above the division, and the denominator, the one that is below the division sign. So our class fractional will have two member fields and will have 5 functions. 2 constructors, the regular ones, the default one, and the 2 parameter constructor. Destructor, surprise, surprise. There's gonna be also the void print, which is gonna print the value of the fractional as numerator value, division sign, denominator value. And finally, I will be writing down this very, very important function, this operator overloaded addition operation. So the prototype of this function will be like this, as you can see. Fractional, the return type. Operator plus, the name of the function. Const fractional ampersand operand, the argument. The only single argument, which is going to be a constant reference to a fractional object. Okay, let's start writing down this fraction class. Or I can write it here, I guess. Class fractional. Public int numerator, int denominator, fractional int num, comma, int denom, num denom. The question also asks us to write down a little bit of a std code, just to show you like which one of these constructors are being called in which scenarios. Std code. Normal constructor. Constructed. Normal constructor. Numerator value blank slash blank, denominator value, and finally std and del. So this is gonna be our normal constructor. Next is gonna be the default constructor. The default constructor is gonna set the value of numerator to 0, set the number of set the value of denominator to 0. This is gonna say default constructor, and that's it. The destructor function fractional. Oops, sorry about that. It's just gonna write destructed, and the rest is the same. Let me write down the void print function first. It is pretty straightforward. I'm just gonna remove this part, and that will be it. Okay. So if I go to main and now define 2 fractional objects, fractional f1, let's say 5, 9. So it's 5 divided by 9. And the fractional f2, let's say 6, 8. And I will have another fractional variable object, which will be initialized by the default constructor. And then I'd like to write something like this. This is my main goal. This is my main goal. I'd like to write down f1 plus f2, sorry, sum equals f1 plus f2. I'm gonna use the plus operator over this over 2 objects of the same class. However, as you can see here, as I write it like this, right now, he just says, I don't know how to add two fractional objects together. This is something unknown to me and you haven't defined it, so I don't know what to do, so this is an error. In order to avoid that error, we have to define this overloaded addition operation. So fractional return type operator plus name of the function const fractional ampersand operand, the single argument of this function. Now, the moment I have declared this function, this is an empty function at the moment, it doesn't do anything, but as you can see in line 75, the error is gone, because now there is a function which is overloading the plus operator within the fractional class. Okay, so here I have to calculate the actual additional result, right? So the general math rules about fractional numbers says if you are trying to add two fractionals, the easiest way of doing it, just multiply the denominators and set it to be the denominator. So result dot denominator equals this denominator times operand denominator. You can leave this part. This is not necessary. Okay, you might be a little bit confused here at this moment. Like, whose denominator is this? So if you're a bit confused, imagine that this is like this is a function like this: f1 dot operand plus f2. So this is a function of the object f1. Therefore, if I say denom, it is going to be the denominator value of the object f1. And f2 is going to be the argument of the function. And it's going to be, this operand is a reference variable, so it's basically going to be another name for f2. So if I say operand.denom, it's going to be actually f2.denom. If I say denom there, it's going to be f1.denom. Technically, you can also write it like this, but this is better and easier to see. So this is our denominator value. What is going to be our nominator value? Numerator value. I will multiply the denominator of one with the numerator of the numerator of the other one. So I will have a cross multiplication. Right? So I'm gonna say numerator times operand dot denom plus operand dot numerator times denominator. So if it is as you can see in the example, 5 divided by 9 plus 6 divided by 8, so the denominator will be 9 times 8, 72. The numerator will be 5 times 8, 40, plus 6 times 9, which is, well, 54. Yeah. 40 plus 54, 94, divided by 72, I guess, if I'm mistaken. We can check it out pretty fast. Finally, I'm gonna return the value of this result back to whoever is calling this operator. Let me run this function. Let me run this code. Okay, so the normal constructor, we have constructed an object with 5, 9, it is using the regular constructor. Another object, 6, 8, it is again using the normal constructor. Sum has been opened up with constructed via the default constructor. And when I go inside this plus operator function, then there is this fractional result, which is again, there are no initial values, hence the default constructor will be called. Then, yeah, this was, as I think we have calculated, 5 times 8, 40. So 40 plus 6 times 9. 6 times 9, 54. Yep, 54, then the result should be 94, and as you can see, it is 94. The denominator is gonna be 9 times 8, which is gonna be 72. So, as you can see, everything is fine here. Okay, so this is gonna be our addition operator for the class fractional. Okay, let's have another example. This time, we'd like to overload the subtraction operator for the fractional class. So nothing so strange here. I'm just copying and pasting this. Since this time I'm gonna be overloading the minus operator, the name of the function changed to operator minus. And how it is calculated, denominator calculation is the same. Numerator calculation is gonna be numerator times operand dot denominator minus operand dot numerator times denominator. And if I put the minus here, so this first one was 40, the second one was 54, therefore the result is going to be minus 14 divided by 72. One more example. This time, let's overload the multiplication operator for the fractional class. Again, I'm going to copy and paste. It's going to be a good starting point. The name of the operator is now changed to star. Denominator is, I guess, the same. Because if you are trying to multiply two fractional numbers, the numerators are multiplied among themselves, denominators are multiplied among themselves. So the second part is the same. The first part is gonna change. The first part is gonna be shorter, numerator times operand dot numerator. And if I call this one here, oh, I made a mistake, so I guess I forgot to use this. Yeah. My keyboard glitched a little bit. Okay, 6 times 5, 30. 30 divided by 72. Nothing so strange going on here, honestly. So these are the list of, this is the list of overloadable operators in C++. So, as I mentioned, some of them are like simpler things, the plus minus, multiplication sign, division sign, percent for the modes, yeah, modular arithmetics, and so on. There are also these comparison operators. There's these bitwise operators. You are not generally using bitwise operators a lot, I guess, in objects, because most of them, what do you mean by shifting objects? Compound operators can be useful, but I don't know, if you are a bit lazy, you can omit those things. And the more sophisticated operators you go, the meaning of overloading an operator will become very weird. So technically, you can overload the new and delete, which is normally they are there. Unlike the plus and minus sign, the new and delete operator are already there. The square brackets is also there, and the regular parenthesis is also there. But when you overload them, you can do very strange things, honestly. With new and delete, still it can be understandable, but the square bracket and also especially the regular parentheses, yeah, I really don't want to cover it in this course. It is a bit complicated, and you can do very weird, very interesting, very crazy things by overloading these operators. As for the comparison operators, let's have a comparison between two tank objects. So let's try to overload the less than operator for tank class based on the following logic. So this is the logic that I have made up for this particular example, don't get me wrong. Normally, how do you compare two tanks? It is, it changes from person to person. So in my logic, this example logic, I say, first compare the armor ratings. The one with the higher armor rating is the bigger tank, whatever the hell that is, well. Next, if the armor ratings are the same, then the one with the higher firepower is bigger. If both of them are the same, then the one with the higher speed is bigger. If all three of them are the same, then they're the same. Come on. So, this was our tank class with the armor rating, speed, firepower, and our constructors. I will be writing down my function here. So I'm gonna say tank operator less than const tank ampersand operand. Oh, wait a second. Do I have to make the return type as a tank? I mean, apparently it is not giving me an error, so technically I can do that. But does it make sense? Because what am I gonna do at the end? Let me comment these parts out. So I will be having, for example, tank 4th division, tank 40, 50, 60. Up. 5th division tank, let's say armor rating 60, speed 70, firepower 80. So I'd like to write something like this: 4th division tank less than 5th division tank, STD code, something very simple. 5th division tank is bigger / better. Else fourth division tank is bigger and better. Oh. Okay. So as you can see, the comparison, this is an operation. This is an operator. So the return type of this operator, as you remember, is gonna be, should be a boolean, because this is how the if statement works. The if statement checks if the end result of this operation is, if it is true. If it is true, then he will execute this line. If it is false, he is gonna execute this line. So the return type of our comparison operator is gonna be a boolean. Then I'm gonna say if armor rating is greater than operand dot armor rating, then return false. If my armor rating is bigger, then less than operator should say no. Else, if armor rating is less than operand dot armor rating, then return true. Else, oh, let me write it like with an else if. I prefer else ifs. Else, this means the armor rating of these two tanks are the same. So the logic says if the armor ratings of the tanks are the same, then you should be checking the firepowers. If firepower greater than operand dot firepower, again return false. Else if firepower less than operand firepower, return true. Else, in this case, the firepowers are also the same. I'd like to say something like this: return speed less than operand dot speed. I mean, I can go over and say if speed less than greater than operand dot speed, return false, things like that. But since this is gonna be a comparison, and the return value of this thing is gonna be true if the speed is less than operand dot speed, and it's gonna be false if the speed is bigger than operand dot speed, and if the speed is the same with the operand dot speed. So from a logic point of view, this is the same. Therefore, I am writing it down because it's shorter, honestly. Now, as you can see, this line is perfectly fine. There are no errors there. So let's run. Okay, Fifth division tank is bigger because fifth division tank has an armor rating of 60. Fourth division tank has an armor rating of 40. So 60 is bigger than 40, therefore the output is fifth division tank. If I say 70, then fourth division tank is bigger. If they are the same, the firepower of the fifth division tank is 80, so it's bigger than 60. It should say fifth division tank is bigger. Yeah. So this is gonna be my less than comparison for the tank class. Let's have a couple of more examples. Add an overloaded greater than sign and an overloaded equal sign for tank class based on the same logic. I'd like to get a little bit we can write the let's write the greater than sign, and then we will add one more example there. The greater than sign is gonna be basically the same thing. Only the arrow sizes, arrow directions will be different. Nothing so fancy, honestly. But let's say if we want to overload the greater than or equal to operator. Greater than or equal to operator. So the greater than or equal to operator is, as you know, is the inverse of less than operator. So if the less than operator says true, this should say false. If the less than operator says false, this should say true. So it's gonna be the reverse of whatever the less than operator is gonna telling me. So I'm gonna say return not something, and that something is gonna be I will be calling. I am the object who has called the less than operator. Who am I? I am this, and I have a less than operator. And if I call that operator with this operand, then this is I am. Whoever has called the greater than or equal to, whichever object has called greater than or equal to function, it is this. And since it is an object of this class, it has this operator less than. And as you remember from the previous example, we have such an alternative way of writing the less than operator. And this function, let's call it a function, has a single argument, which is gonna be the operand, whatever the operand that is passed to me. So I'm gonna call the less than operator over the operand, and I'm gonna not the result. So I'm gonna say whatever the result of this thing, change it, flip it. If the result is true, then say false. If the result is false, then say true. You can write things like this because of the, again, shortening the size of the code. Finally, bool operator equal const tank operand. In this case, I'm gonna say return armor rating equal operand dot armor rating, and then firepower equal operand dot firepower, because it is there two tank objects are only equal if and only if their armor rating, firepower, and speed are the same. So I'm combining these two comparisons with two and comparison operators. Are they called comparison? I'm not sure. I think logical. What did we call it? I'm a little bit confused. Yeah, logical operator. That's speed. Okay. So let's try these things in our code. So first of all, let's try the equal. Wait a sec. If 50 division tank equals 4th division tank equal 5th division tank, these tanks have the same capabilities. I honestly don't want to say equal, because equal might have a strange meaning for some people. Some people might think that these tanks objects are the same object. If you are saying same, some people may confuse it as same objects. Therefore, instead I'm saying same capabilities, because 4th division tank is a separate object, 5th division tank is a separate object. I'm just comparing their internal values. Okay. So tanks have different capabilities. If tanks happen to have 50 and 60 here, then it's gonna be the same. These tanks have the same capabilities. I think that's gonna be what he's gonna say. Yep. Okay. One last type of operators that we did not cover in our previous big table is typecasting operators. So if you remember, we also have the capability of converting an integer into a double into an integer, char into an integer, one primitive to another primitive, by using down this, like, within parentheses double, within parentheses int. And those were the explicit typecasting operators. So we can overload even those things in C++. If you are trying to overload these things, the syntax is a little bit different. You don't have a return type. You don't have to write the return type. You write the operator keyword and follow it with whatever the type you want to be casted into, and then you do not give an argument. By the way, short error scenario. In this fractional plus minus operators, if I try to write down another argument, let's say I'm writing it like this, he's gonna say no. Overloaded operator minus must be a unary or binary operator. It cannot have 3 parameters. Okay, so technically you have to have either 1, or I think you can get away with 0, but 0 would be a bit weird. So generally you have to go with 1 argument, but you cannot go with 2 or 3 or whatever. You have to have 0 or 1 arguments. Similarly, for this fractional, you will see that you cannot write down any arguments. Okay, let's have an overloaded, let's write down an overloaded double operator for the fractional class. So I am gonna comment the tank part out, and I'm gonna comment in the fractional parts first. Then I'm gonna say operator double. How am I gonna convert a fractional number into a double? Well, simply I'm just gonna say return double numerator divided by denominator. I have to write down this double because, as you know, numerator is an integer and denominator is also an integer. We have defined it like that. Therefore, if I simply write down numerator divided by denominator, then it's gonna be an integer division, and this is not what I want. So if I say sum.print and then let me change it to plus, and then I'm gonna say std quote double casted sum std endl. Okay, so apparently 94 divided by 72 is 1.30556. So this is how you write an overloaded typecasting operator. Again, if you're trying to write something like this here, he's gonna say no, conversion function cannot have any parameters. If you're trying to write down something like this, conversion function cannot have a return type. So C++ is pretty strict over these things. One more example. Add an overloaded int operator for the fractional class. So this is gonna be very simple. Just copy and paste this thing. Instead of the double, I'm just gonna say int, and I will just gonna lose this part. And then if I write it like this, he's gonna call the integer typecasting operator, which is gonna say only 1. Because 94 divided by 72, if you are making an integer division, the result is gonna be 1. Because the fractional part, you cannot put it inside this integer value. So the thing is, other operators, if you are trying to overload more complicated things, then things start to become a bit tricky. That's why I will not go into the details about those things. Maybe in some future lecture, I think it's gonna be more suitable for an advanced C++ course, overloading the square brackets, regular parentheses, news, deletes, new and delete with the square brackets, things like that. Compound parameters will be pretty straightforward. Again, the bitwise operators should be pretty straightforward. This comma thing would be a bit weird. Assignment could be weird. And again, this dash arrow thing and dash arrow star could be pretty difficult. At this moment, you might be asking one big question. What to overload, basically? Which operators should I overload? And when should I overload it? So basically, Master Yoda has a bit of a comment on this topic. So if your operator overloading is a very powerful thing and a very powerful aspect of C++, I can clearly say that. And if you are writing down things like this seems pretty good. For example, if you are trying to write the same thing in Java, you have to write down something like this, which is much less beautiful. Because if you are trying to add multiple things, this works in C++. You can add many times. I mean, you can use it as many times as you want. But again, add F2, then you have to say the return type of this thing is a fractional. Then you have to say something like this. Then after a while, it becomes very complicated, difficult to read. I mean, you can live with that, don't get me wrong. Java coders live with these kind of things all the time, but this is simpler, easier to understand, easier to grasp. But the thing is, you do not have to overload. The magical rule is you do not have to overload every single operator for every single class. Generally, the operator overloading works very good with math-based classes. Hence the fractional example. Another example could be like using complex numbers with the imaginary components. Again, in those kind of scenarios, operator overloading makes a lot of sense because, you know, adding two imaginary numbers does make sense. There is a mathematical equivalent for that. Adding vectors, not our C++ vectors, really geometry vectors. It makes sense because there's a vector addition, there's a vector subtraction. In other cases, generally, the ground rule is operator overloading, overload operators if really it does make sense. If like adding two tanks doesn't make any sense to you, then don't. But if like comparing two tanks does make sense, then do it. That's gonna be the golden rule about operator overloading. That will be it for this part. In the next part, we'll be covering the exception handling. Thank you for listening. I hope it was educative, it was useful. See you next time. Bye-bye.